Okay, what we're going to do is another forward and backward scan. So remember, the way we start a forward and backward scan is we draw up these boxes under or next to the vertices so that we can write the earliest and latest start time of the particular tasks in them. Remember, there's heaps of different methods of doing the forward and backward scan. So this is the one I like, so I run with that. But yeah, you run with whatever works for you. Now, the way we start the forward scan, and I'll do that in orange, is the start always has an earlier start time of 0. That's the earliest we can get it going, is straight away, 0. So let's go forward and see what we can put down here. We've got 0 plus 6 is 6. That basically means the earliest we can get D and E going is at time 6. That's because A starts at 0 and will go for a duration of 6. Okay, let's go down this edge here, and so what we've got leading into this vertex here is 6 and 7, so E will be 13. Now you'd be tempted to write 13 in here, but let's hold off for a moment because we need to consider the value coming in here off this edge here. So let's write down underneath the box what E will be for future reference. So 6 and 7 is 13. Now let's go down the bottom now. There's no particular order you have to do them in, so you just keep chipping away until you get the values. But let's do B. So 0 plus 3 is 3. 3 plus 5 is 8, so C will be 8. Now, this is what you've got to think on the forward scan. Largest value goes into the box. So we're going to pop the 13 rather than the 8 into that box. And that basically says that the earliest we can start task F is 13. Now, why 13 and not 8? Have a look. A is 6, E is 7. They'll take 13 units of time. B is 3, C is 5. That'll take 8 units in time. So yeah, that's great. But I can't write 8 because I can't get these two going until these two tasks have been completed. And at minimum, they'll take 13 units of time. So the earliest I can get F going is 13. Now you've got to understand that. If you don't understand that, really spend some time thinking about what these things are supposed to represent and make sure you have a good understanding of that. That's so important. You can't just rote learn forward and backward scans because there'll always be a question down below somewhere that really tests your understanding of the overall concept. Alright, now let's go forward a bit more and see if we can get this one done now. Now this one here depends on F, so again the value we won't pop it in there straight away, but we've got F is 13 plus 4 is 17. And we've also got potential from D. D is 6 plus 8 is 14. Where is it? Let's just see if I'm getting this right. 13 plus 4, F is 17, yep, and D is 6 plus 8 is 14. So that's the other lesson in this. Sometimes you really need to stop and think a little bit. You just can't sort of go on autopilot and do a forward and backward scan, so always got to be thinking. Alright, largest value in the box, 17 goes in there, 17 plus 8, 25. Okay, done with the forward scan. Now the back scan, which I generally find a little bit harder to do. 25 take away 8 is 17. So the LST, or the latest start time of this task here, is 17. And what we can see pretty quickly here is that this task here must be on the critical path. So its earliest start time and the latest start time has to be the same thing. Any delay in the start time of this task here will delay the overall project completion time. Alright, going back from 17, let's go up to here. Okay, now the way we work out later start time is we go 17 take 8 is 9. Can't write 9 in there yet, okay, because I'm going to write D9, and the reason is I've got E coming in here as well. Okay, so I'll need to consider E before I write down a value there. So that's really similar to what we did with these orange ones on the forward scan. Alright, let's go with the LST of task F. The way we get that is 17 take away 4 is 13. Now, let's go 13 take 7 is 6. Okay, so 13 take 7 is 6. These are the potential values that go into the box. And it's a little bit different from the forward scan. Remember forward scan? Largest value in the box, largest value in the box. Well, with the back scan, what we do is we pop the smallest value in the box. 6 goes in there. Alright, now we can go 6 take 6 is 0, but this task here, the start, or this vertex here has A and B coming out of it. So we need to consider the value of A. 6 take 6 is 0. Now I know that's going to be the value because yeah, that line there will be the critical path. Okay, but let's just check it out anyway. 13 take away 5 will be 8. And 8 take 3, B is going to be 5. Okay, smallest value in the box, a 0 goes in there. Alright, so forward and back scan is now complete, and that will really help us fill in this table here. Now, this method that I'm using, the only thing that we really need to crunch the numbers on is this column here, the LST. The rest of it's fairly easy to generate. If you put these boxes over the edge rather than the vertice, you can get these out really quickly. Okay, but yeah, each has its pros and cons. Again, experiment and kind of see what you like. Okay, let's go with task A. It has a duration of 6, no predecessors. It's earlier start time 0, later start time is 0. Now the way we get that is we go 6, take away 6 is the later start time. It's got 0 slack time. Alright, let's go with task B. Task B has a duration of 3, doesn't have any predecessors. Earliest we can start it is 0. The latest we can start it is 8, take away 3 is 5. Actually has a slack time of 5. Okay, let's go with task C now. C has a duration of 5, predecessor of B. Earliest start time of C is 3. Latest start time will be 13 take away 5, 8. Has a slack time also of 5. Now that makes perfect sense because this whole path, if I follow edge B and C, it has a total time completion to this point here of 8, and this path here has a total completion time of 6 and 7, 13. Now what's the difference between 13 and 8? It's 5. So this task here will have a total slack time of 5. This task here will have a total slack time of 5. Any number other than 5 that came up there, I would have known that I've done something wrong at some point. Alright, task D. Let's see, that duration is 8. It depends on task A. Earliest start time is 6. I'm just getting that value from there. And the later start time I get by subtracting, I follow the edge down and I go 17 take away 8 is 9. It has a slack time of 3. E, where are you? 7 is its duration. It depends on task A. Earlier start time is 6. Later start time 13 take 7 is 6 as well, which means it's on the critical path. Has a slack time of 0. Almost there. F. Duration of 4, depends on E and C. Earliest start time of F is this value here, 13. Later start time is 17 take 4 is 13, also on the critical path because it has 0 slack time. Alright, now we're almost there. G has a duration of 8, depends on D and F. earliest I can get that going is 17, this value here. Latest that I can get it going is 25, take 8. Well, we know that, again, that has got to be 17, slack timer 0. Okay, so table filled in, critical path. We can pull that out of this table here by looking through at all of the vertices, the activities rather, that have 0 slack time. So A followed by E followed by F followed by G. Let's just draw that onto the diagram itself. A, E, F, G. Alright, so that's our critical path there, and our very last question says the minimum time for completion. Well, the minimum time for completion is the longest path through the project, and that's basically the earliest and latest start time at the finish vertice. So it's going to be 25. Done.